Good morning, pre-calculus. Hey, today we get to look at section 10-7, dealing with polar coordinates. And the big question we need to answer is, how do you describe the position of a point in a plane using distance and angle rather than x and y coordinates? All right, that's what we're going to do today. So, we'll do it in two parts. Today, we will look at coordinate conversion, and then next section, we'll look at equation conversion. So everything that we're going to deal with in this section deals with this first part of page 780 to 781. Polar coordinates are related to rectangular coordinates. Now, what does that mean? Okay, what I'm going to do is, this is a document that I got off of the internet, and this is a polar coordinate graph. And you can take and relate this to a regular Cartesian coordinate plane. So again, if you look at here, like this is your x-axis, this is your y-axis, and what we're going to do is pick out a polar coordinate, and we're going to look at its polar coordinates or its rectangular coordinates. Okay, that's what we're going to do. It's not that difficult. You can find this on the internet. All I did is plugged into the Google polar coordinates graph PDF, and you can get any different any style you want. Okay, so we're going to do coordinate conversion, and we're going to do it two ways. One, we are going to look at this part right here. This is called a polar coordinate. Deals with the radius and an angle. Now again, you should be familiar with this. We did this back when we talked about vectors. Again, a vector relationship is your terminal point, so to speak. This is the terminal point of an angle measure. Okay, so we need the radius, and we need to know what the theta is with respect to the unit circle. Then over here to the right, this is a rectangular coordinate. That's the same thing as saying a Cartesian coordinate plane. Same thing, okay? So this whole table right here, this whole box right here is crucial to section 10-7. And we're going to go to do some examples of we're going from a polar coordinate going to a rectangular coordinate, where in this case, to go from polar to rectangular, you'll be given a radius and an angle measure. And from here, we know, we did this a while back when we did the unit circles. We know our x value, or our x component, will be the radius times the cosine of that angle, which all goes back to the unit circle. And your y component is related to the radius times the sine of that angle, which goes back to the unit circle again, that y value. You'll see. Then we're going to go from rectangular to polar. So rectangular and polar, once again, we want to go, we're given a rectangular set of numbers, and we want to go to polar. Rectangular to polar, and from here, we need two things. We need to know what the radius is, and we need to know what theta is. So again, I wrote it differently here. The radius is nothing more than ties into the Pythagorean theorem, and your theta is related to the tangent of y over x. So this whole part right here is very crucial for this section, okay? You'll see why, especially when we get to Roman numeral 2, when we're dealing with equation conversions. Well, the only way to do this is by example. So here's a set of examples. We want to convert each point to rectangular coordinates. So in other words, we're going to be given a polar coordinate, and we want to go to rectangular. Again, you are more than welcome to use this thing here, use this graph paper. I'm just going to focus on a couple of these examples and then illustrate it on this picture. It should help out. Okay, so the first one is this. I want to go and find out what the rectangular coordinates are when you're given a polar coordinate of 4 and pi over 2. So we want to find out what those are as a rectangular coordinate. So, like I said, everything ties into this table up here. So if we're going from polar to rectangular, we need to find out what our x component is. So that means we got to go take the radius and multiply it times the cosine of what our theta is given. To find our y component, we got to go the radius times whatever the sine of theta is. All right, so let's look at it. So you're given our theta. So again, we have to find, in this case, we have to find the x coordinate. So x equals r cosine theta. We already know up here our radius is 4, and we want to find the cosine of pi over 2. Now here, in the cosine of pi over 2, you've got to go back to your unit circle. Remember, cosine is the x component. So again, we got to ask ourselves, what is the x component when our, in this case, our radian measure is pi over 2. We know it's going to be 0. So that means our x coordinate as a rectangular coordinate will be 0. Over here to the y, same thing. R times the sine of theta. Radius, which is 4, times the sine of pi over 2. Going back to your unit circle, go to the pi over 2. Ask yourself what the y component is at sine of pi over 2, which in this case is 1. And we get 4. So here we know that 4 pi over 2 as a rectangular coordinate is 0, 4. Now some of these are going to be relatively easy. So if you take this and go to our polar coordinate graphing paper, okay? Remember, 4 is your radius. Pi over 2 is right here. So if you look at it, this problem here, this is 1, 2, 3, 4. So if we were to look at this part right here, this right here would be the picture of the polar coordinate, the graph of the polar coordinate, which is very similar to when we did vectors. But now, if we were to look at it in relationship to the x and y axis, that's the point 0, 4. So this right here would be the graph of 4 pi over 2 as a polar coordinate, and 0, 4 would be an example of this as a rectangular coordinate, or if we have a piece of graph paper behind that. Okay, that is example 1. Let's try something else. All right, let's say number 2. We have the polar coordinates of 2 pi over 6. Once again, we have to do a little bit of thinking. So we go for find our x coordinate. We know that it's going to be 2 times the cosine of pi over 6. We need to go to our unit circle, ask ourselves what the x component is at pi over 6. It's going to be radical 3 over 2. We multiply it by the radius, we get radical 3. Same thing with the y coordinate. We go r times the sine of theta. So we need to find out what the y value is of the sine of pi over 6. So you go to your unit circle, and it's going to be 1/2. And then from based upon this, this right here will be the rectangular coordinates of this polar coordinate. All right, now the next part of Roman numeral 1 is taking now rectangular points and converting them to polar coordinates. Now, like I said earlier, this part right here is the crucial part. We did this part right here. We went from polar to rectangular. Now we're going from rectangular to polar, and we're going to have to use this information. So how do we do it? Well, let's take the point 2, 2. Now again, just to give you guys a little bit of idea here, if we were to stop and look at this, and well, we can't use it that way because you can't confuse rectangular with polar. Okay, they're a little bit different. So here we have the point 2, 2. X is 2, y is 2, and we want to go to polar, r theta. So we have to find our radius, and we have to find our angle measure. And the angle measure can either be in radians or degrees, but I think we're going to keep it in radians. So let's do it. I did it on both sides. To find our radius, we use that formula. Like I said, everything ties into this part of the this part of this table here, okay? So we take x squared and y squared. We want to find the radius, so we take the square root of both sides. I'm showing all my details here in a second, okay? Again, so 2 squared is 4, 2 squared is 4. This becomes the square root of 8, and the square root of 8 gets simplified to 2 radical 2. But now, please, so there's no confusion, our radius is always going to be a positive value, so our radius is going to be 2 radical 2. Okay, now we got to find theta, so we go back and use our formula. The tan of theta is y over x, which in this case is 2 over 2. Now to figure out what that theta is, we got to remember we have to go back and use the trig equations. So we know tangent is sine over cosine. So we got to ask ourselves, there's another step here. Okay, we know that's going to be 1 over 1. So we need to ask ourselves sine of 1, or in other words, what is the y value that will give you 1, and what will be the x value that will give you a 1 in your unit circle. In this case, it's going to be pi over 4. You have to go to unit circle. That is something that we've done before, so we get to use it again. So that right there is your polar coordinates of 2 radical 2 pi over 4. Let's see. If I go to my calculator, that's what, 2.8. So if we were to go and graph this, we know 2, 2 as a rectangular coordinate, as a polar coordinate, will be along the pi over 4. And it's a little bit close to 3. So 1, 2, 3, roughly here. That right there is our polar coordinate. All right, number 4, we have the x component of -1 and the y component of 0. We want to put it into polar. Same thing again. Again, setting it up, we're going to see that our radius is going to be 1. And over here, tangent of y over x, once again, it's y is 0, x is -1. But we know that 0 divided by -1 is 0. So we go to our unit circle, ask ourselves the sine of what value divided by the cosine of what value will give us a 0. And the only choice is going to be pi. All right, so that means over here in this example, we know that the radius is 1. This right here would be the polar coordinate of -1, 0. So that'd be 1 pi. All right, that's where I'm going to stop here on this part. Yeah, I got one more. I got to give another challenging one, okay? Number 5. One more. Here we have the point -1, -1. That's our rectangular coordinate. We want to make it into a polar coordinate. So the first things first, figure out what the radius is. So again, like I said before, everything gets related to this box right here. We get to use this part, then we'll use this part. So the radius is going to be the square root of 2. So I'm just doing this, setting it up in a minute. Tangent of theta is y divided by x, so it's -1 divided by -1 gives us +1. But a moment ago, we said that the tangent of 1 over 1 was pi over 4. But now, I'm giving you 5 pi over 4. Your brain is already should be thinking, why? Okay? Your brain should be thinking, why is it 5 pi over 4 instead of pi over 4? It has to go back way up here to this coordinate of -1, -1. And if you look at that, that is in the third quadrant of a Cartesian coordinates plane. It's in the third quadrant. So that tells me, okay, that my angle has to be also in the third quadrant. So once again, if you treat this as the x, y axis, quadrant 1, quadrant 2, quadrant 3, quadrant 4, and if you look at the coordinate system, the rectangular coordinate system, we know that x is -1, y is -1. It's going to be in this quadrant right here. So that tells me that this problem right here is going to follow along this part of it. So we know that if we were to go and do our check into, that's about 1.5. So again, this is 1, 2, that right there is the polar coordinate of the rectangular coordinate of -1, -1. I think I'm going to stop there. I gave you guys quite a bit of information that you can look at. Again, don't be afraid to open up your textbook. I have never known any math person to die from thinking. And if that's the case, yep, we'll move on. Okay, so again, the whole key to this section is this part right here. And you'll see more of its use in Roman numeral 2. All right, I'm going to stop right there. Next video will be the second part of section 10-7, polar coordinates. All right, guys, catch you later.